Okay, here's section 3.6, rational functions. We haven't dealt with a whole lot of rational functions, at least as far as graphing goes. There's only I think four problems we're gonna work, maybe five, but there's just some information we gotta get through first, so be sure you pay attention to this to make those problems easier and take good notes. So a rational function is like a rational number, like 3/2, right? So a rational function is going to be some sort of polynomial over another polynomial, something like this. This is what we've been synthetically in, using long division to divide. But now we're just going to graph. So you know domain is all x's. So for a rational function is going to have polynomials with no square roots. So it should just be the domain you're looking for should be everywhere except where the denominator can't be. So remember, to find domain, you'll set your denominator equal to 0, and whatever that is, that's what the domain isn't. Okay. We've done that a lot. So it actually gives us, I went ahead and gave you the solution here. If I graph 1 over x, so that's the basic rational function, that would be the parent function for rational functions. I just want to show you what they did. They tested both sides, because here the domain, you would say, well, the denominator can't be 0, so it's all real numbers except x is not equal to 0. And so it says we know it's not defined for x equals 0. Let's see what happens as we get close to 0. So this says I'm trying to get to 0 from the left. That's what that says. From the right, the little plus or minus afterwards says you're approaching it from the left or you're approaching it from the right. So if I have a graph, we're looking right here at this 0 and seeing what happens. So we graphed negative 0.1. So if this were like 1 was way out here, negative 0.1, 0.01, 0.01. So we're getting smaller and smaller and smaller than negative, and so we're testing these points this way. And you can see it gets bigger and bigger and bigger in a negative way. So it's going this way. You could say, like, as x approaches 0 from the left, then y, f of x, is approaching negative infinity. So as I get closer to 0, we don't really know what it's doing, but we know it's coming in like this and getting all the way down there. Okay. And then the same thing over here. As x approaches 0 from the right, so I'm coming in this way, it's getting bigger and bigger and bigger. Y is approaching infinity. So I know it's doing something. And that's what your graph of 1 over x looks like. A little bit neater than that, but that's what it looks like. That's what your rational function looks like. I'm definitely going to have some asymptotes here. You'll remember those from last year. This is just a good rule of thumb that I think helps. Maybe you don't think this way, but 1 over a big number equals a small number, right? 100's big. 1 over 100 is a small number. 10 is bigger than that, but that makes 1/10 a smaller number. So the bigger number is in the denominator, the smaller the number actually is. Okay, here's another one, same thing. So just that notation, as it approaches, you can see all this, approaches from the right. Just want you to be familiar with that. And then ultimately, here's the graph that we just sketched. Okay. So you can see some of that language here that I do want you to be familiar with. Okay, now let's talk about asymptotes. Vertical asymptote, obviously looking something like this. Horizontal asymptote, looking something like this. Your vertical asymptotes you're going to find those where the number doesn't exist. So this is going to be like once you find your domain, right, or where x doesn't exist, which will involve your denominator. That's the vertical asymptote. Horizontal asymptote, we'll look at it another way. Notice this is a horizontal asymptote because it never approaches this number. This is a horizontal asymptote because way over here it won't approach that, but it does pass it over here, and that's okay. Here's your horizontal asymptotes. So it says for vertical, right, it's where the 0 of the denominator, like we said up there. For horizontal, you're going to take the fraction of the leading terms if they are, like this is x to the n, x to the n. You take the leading terms, and if this power n is less than n, so this means if it would be like x squared over x cubed, okay, something like that. So with a bigger one on bottom, its asymptote is at y equals 0. But if it's like x cubed over x squared with the bigger on top, then it doesn't have one. And if they are the same, so if it's like 3x squared over 5x squared, right, my degrees are the same, then it is the ratio of those coefficients. So my asymptote is going to be at y equals 3/5. Okay, so we're going to do this. Make sure you remember your asymptotes. So an vertical asymptote is going to look like this, and so that's at x equals a number. Your horizontal asymptote is going to look like this. So it's going to be y equals a number. So make sure you use correct form there. Okay, and that says when we're graphing rational functions, you are going to find the intercepts, find the vertical asymptotes and horizontal asymptotes. And that's how we're going to get our graph. So first thing I want to do is find, let's find vertical asymptotes. Vertical asymptotes are found where the domain where the domain doesn't exist. So you will always set your denominator equal to 0, and that is where your vertical asymptotes are going to go. Now, to solve this, we can t-chart it, and I get -1 plus 2. -1 times 2 is a -2. -1 plus 2 is 1. So I have two vertical asymptotes, x equals 1 and x equals -2. Both of those are vertical asymptotes, so that's the first part. Next, I need to find my horizontal asymptote, and that's remember those three rules. And like, seriously, this box right here, like, star that. You need to come back to that. You basically need to have that memorized. So for vertical asymptote, you set denominator equal to 0 and solve for horizontal asymptote is when you look at the leading terms. And so here my leading terms are 2x squared and 2x squared. They're the same degree, both 2, which falls into that middle category, which tells you, you look at the coefficients. So my coefficients here are 2 and, let me copy that. Right here I have 2x squared over x squared. And my leading coefficient simplified to 2 over 1 or 2. And it's a horizontal asymptote, which is going to be a horizontal line. Remember, y is y. So this is a vertical asymptote. This is a horizontal asymptote. Okay. And the other thing it says to do up here is to find your intercepts. Okay. We will find our intercepts by setting the whole problem equal to 0. But whenever I do that, sorry, I say intercepts, I mean x-intercepts. Whole problem equal to 0. Okay, sorry, I had to make more room, so I moved that over here. I'm finding my x-intercepts. X-intercepts are zeros, right? So I'm going to set the whole problem equal to 0 and solve. Well, the first thing I'm going to do is multiply this on both sides. And it cancels. This is always going to happen. So what you can do to find your x-intercepts is just set your numerator equal to 0. So I now have 2x squared plus 7x minus 4 times 0 times 12, which is 0. And now I can factor or t-chart, and they need to multiply to be a -8 and add 7. Okay, and I have 4 and 2, which doesn't work, so it's going to have to be 8 and 1. And one of them's a negative. I'm going to do 8 and then subtract 1. So I'm going to stick my 8 with my 2 and my 1 with my 4. Greatest common factor. Factor out a negative. A lot of room, sorry. This is old hat. You totally know how to do this or better, or you need to come see me. 2 minus 1. Now I can find my two zeros. X equals -4. And then 2x equals 1, x equals 1/2. So those are my two zeros or my x-intercepts. I'm going to put that up here. Okay, so I made my x-intercept over there. Now I'm gonna find my y-intercept. Remember how you find your y-intercept is you plug in 0 for x. So I did that and I simplified and I got 2. And so now we have this nice list of our 4 things. And every time you're graphing a rational function, you need to find these 4 things. Now you can graph on a, remember it's my y-intercept, so it's where it's gonna be equals to. You can graph this on your calculator and get a good idea. Absolutely do that. That's fine. I will expect you to do all of this though on the calculator portion as well. So to review where these numbers came from, my vertical asymptote came from setting my denominator equal to 0. Okay, so that's what we get. Vertical asymptote. Horizontal asymptote you get by comparing. So these are the 4 things you need to find. Comparing the leading terms. And there's 4 things here. And you can look back up at that box. I'm going to say bigger power on top, higher power on top. Okay, so the situation we had here was the same power, which was where you take the ratio. Bigger power on top, it's going to be y equals 0, and bigger power on bottom is going to be and so this is the first thing, vertical asymptote. Second thing is horizontal asymptote. Third thing is x-intercept. In order to find the x-intercept, you plug in 0 for y, which is ultimately going to be setting the numerator. And then the fourth thing you'll want to do is find the y-intercept. And I fully expect you to know how to find all of these. Find y-intercept by sorry, 0 in for x. Remember to plug x in for 0, you get y in for 0, you get x. Okay, so those are the 4 things we did. That's the 4 things you should do on every rational function. And now we're going to graph it. So I'm going to take my vertical asymptote. At x equals 1, we mark asymptotes with dotted lines. And at x equals negative 2, I'm going to take my horizontal asymptote at y equals 2. So I know it's going to run along those. And then I'm going to graph my x-intercept at negative 1, 2, 3, 4, and 1/2. And y equals 2 on the asymptote. Okay, now that we've done that, graph those 4 things, we just need to finish putting together our graph. Now, the book goes through the process of like testing some of these points, and you can of course test them and plot them and then plot your graph. But we can also use duplicity here, the multiplicity, to help us. And so, first of all, just look at this middle section between my oranges. I know these asymptotes, it's going to go to infinity and negative infinity somewhere, or both infinities or whatever. Well, if I know it goes this way, and then it goes up to that, right? I know it doesn't come back down because it doesn't have another 0, so I know that looks like that. I mean, like I said, it doesn't have another 0, so I know it doesn't come back down, so I know it looks like this, okay? If you don't get how I found that out, well, try to draw it another way. It doesn't work, okay? But you can always test points if you get confused. Test -1 and plot that point, and then you'll see it goes this way, and you can graph that. But then the book doesn't teach this, so you can do it this way, or you can look at the book and do it its way. But I can use that multiplicity. So when we found our x-intercepts, they all came from a power of 1, right? So they all had an odd multiplicity. So it's going to go in the opposite way. Sorry, that was for my asymptote. They came from a power of 1, and so they go in opposite ways. So since this is going down to negative infinity, I know this one is going to go up to positive infinity. And then I know I have an asymptote here, so it's not going to cross, it's going to go that way. Same thing here, this was odd, so I know at this asymptote, one's going up, so the other's going down. So that means this one's going down. I know it has to cross that 0, and then I know it goes like that. And I've sketched my graph. Again, you're always welcome to test points. and that would totally get you that as well.